Hey everyone, I'm Sushant. I work at Google DeepMind on post training specifically for improving coding capabilities of large language models. And I'll be sharing a bit about how post training should apply to building agents. Agents is an overloaded term, so I want to make sure we set some perspective for what agents effectively are, when is a good use case for building agents, and especially what are not good use cases that are applicable to agents, and go into some details there. So our agenda for today should look like setting some perspective. Like I'll quickly go over some background on what post training actually is, so we are on the same page, because a lot of the details of how post training works will actually be useful for setting the ground for what we can actually do with agents versus what is harder to do. Then we'll define what agents are, when to use agents, and like I said, more importantly, when to not use agents. The core sort of building blocks to start building up more and more complex production patterns, the best practices based on my experience and the best practices I've seen in industry, and then summarize to by giving a good decision framework for all the things we've discussed so far. To get started, I'll give some context about post training in general, and why, especially why do we need post training. So uh, once we have a pre-trained large language model checkpoint, it's actually not that useful for public user interactions, because it's only good at next token prediction. So once you give it some context, basically its task is to complete that sentence or predict the next token, which, while it's a useful capability to have and it's a good training objective for large language models, it's not sufficient to actually complete real world tasks or tasks that are actually helpful for humans. So this is where post training steps in, where we take this huge pre-trained large language model, but we actually want to align it and make it useful for real world tasks. So the green circle is where you see we'll actually, the large language model is now has several capabilities that we added after post training. So these capabilities could look something like it's better now at following instructions. It actually has some idea what human preferences are, because that also goes into post training, and we'll go into some details there later. It should be aware of what harmful behaviors are, and how to refrain from those. And then also, very importantly, we want to improve its skills across several different verticals, such as reasoning, factuality, coding, and tool use, which are essential for it to complete actually useful tasks that we want to do in our real life. Uh, so post training, a very simplified view of it is that you can think of it in like these three approaches. So you'll start with a base model, like I said, but which should be instruction tuned. So all that means is it should be good at following instructions, which is how we can then improve it on a wider variety of tasks, like we discussed before. We'll also collect then preference data and train a reward model. This is important because this is supposed to help give the model an idea about what human preferences are. So, given a context and given two different responses, the model should ideally have a sense of what a human would prefer in that scenario. And this is where preference data and training a reward model steps in. And then we'll fine tune with RL with the reward model we just trained to kind of help align our like initial model to what the reward model thinks are good responses given a specific context. Uh, So, besides the three steps I mentioned, some more details about like frontier model post training, and I put an asterisk here because um, a lot of the details of what goes on in these frontier labs are not known, but our discussion will be mostly based around what the best models in the open source community are doing and the information that's publicly available. So, the idea is, again, like I said, to improve across a lot of capabilities, a lot of evaluations, and then what is also different is a lot of synthetic data and a lot of expert human data is used to make these models specifically better in things such as coding, reasoning, factuality, tool use. So this is how a general pipeline for post training looks like. Like you start with a base model that's capable of following instructions. You'll then have again some very high quality data and then fine tune it on base of that to improve it across some capabilities that you want to hill climb on, that you want to improve on. You'll typically also, like we were discussing before, train a reward model based on human preferences, and this reward model will then be used in some sort of RL algorithm. For instance, I've mentioned PPO here, but DPO is also something that's used, and you can. The algorithm doesn't matter that much, but basically the key summary is that you'll have a reward model which helps the LLM to kind of align better with human preferences, and then you get with the final align model that you can use for whatever downstream use case you had in mind. Uh, this is another similar pipeline for Llama 3.1, which was a great model, and also Nemotron from NVIDIA. So again, some aspects are similar, but basically you have this iterative cycle where you start with your best base model that you have so far. You do your instruction fine tuning to make it better at following instructions, and then you have a reward model and you use that in, like I said, either PPO or DPO, and then you end up with a better model, and then you'll keep going and you can keep repeating this loop to kind of keep improving iteratively, and you'll end up with a better and better final model. Also, one thing I want to call out here is with each final model, you'll kind of see some loss patterns, which is why you need to keep doing this iteratively, and sometimes you need to do this a lot, because every time you have a better model that's improved across some dimensions you care about, typically it will have new loss patterns that you've not seen before, and this is where this iterative process will help in. Here's another similar pipeline. I'll not necessarily go into the details of all the different components here, but again, it's very similar to what we discussed before. This is again for Llama 3 from their tech report, which I would also really recommend reading. But this is basically just iterative SFT and RL, like we discussed before, to keep ending up with a better and better base model. I'll quickly also touch upon reinforcement learning basics before we get to agents, because this is a critical part of how actually useful agents are trained. So, uh, like typically, the basic terminology here to keep in mind is you'll have an agent which is interacting with an environment. So it's at any time it's at a given state st, and all the agent can do is take some action which will give it a reward, and the agent's main and only objective is to maximize its expected reward over long horizons. How this applies in case of large language models is basically that, excuse me, that the agent is basically the language model that we are trying to train and we are trying to improve. The action in this case, like how, so it could be different if your agent is actually, let's say if you're in robotics and you're talking about a robot which can take some physical action. For large language models, the action we're talking about is completing the prompt or predicting the next token. Your environment could be some reward model or some other environment that you've set up that basically gives it a reward based on the token it completed. So let's say it completed, you gave it a context and it completed that sentence. So you'll give it some reward based on the overall sentence looks like, or whatever metric you have in mind. And then it will use that reward that you just gave to keep on improving. Yeah, so this is again this pretty standard, we call it RLHF, which is reinforcement learning from human feedback, because typically your reward model is trained on human preferences. So the idea is that if you use a reward model in RL, it will make your language model better at following human preferences, or basically that your model will do what a human would have done in that context. This is similar to what we discussed before, that you'll have your prompt, your large language model will typically complete that prompt. Based on that completion, it'll get a reward. And then it will try to basically, based on the reward, what RL will do is basically make that model more prone to coming up with completions that have a higher chance of getting a better reward. One modification that I want to quickly touch upon is, which has become really popular this year and has been a big part of how RL has been scaled, and we have been getting better models, especially on things like coding, is RL with verifiable rewards, where you don't need the expensive process of training a reward model from human preferences, which can be expensive to get, but you actually have these like verifiable rewards. So for instance, for things like coding, for instance, it's fairly easy to know if your model actually wrote the correct code or not, because you can run a bunch of tests and you can give it a score of like 1 or 0 if the code was correct, 1 and 0 otherwise. So in a lot of domains, this is especially true for things like math and coding, which is also why you'll see models have gotten dramatically better in these things because it's easy to scale RL there. But you can remove the reward model completely and you can have these verifiable, like easy to check rewards. And then you can just scale this so much more because it's easy to get this training data. And you can throw in a bunch of compute at this and you'll get like models which are really good at these like verifiable domains. For other domains, this is harder to do, but which is where a lot of research is focusing on this year. Uh, awesome. So I think we've now set up a good background of what post-training is and how it will apply to agents, which we discuss going forward. So basically, I want to spend a slide discussing what agents are because I feel that's an overloaded term. So I think, in my perspective at least, I think of agents as basically a model which has some agency over tools and actions. Like there are some decisions that that agent can make, which might depend on the context or what the task is and what context it has seen so far and so on. I also want to call out this distinction between workflow and agents. Workflows typically, in my opinion, are something which are much more simpler. So you'll have something more predefined. You have sort of a deterministic path where the agent sort of does not have to take any non-trivial decisions. Whereas for agents, on the other hand, like they should be capable of dynamic tool use. They should be able to do planning, and then let's say have sequentially should be able to call like these real world tools. For instance, doing a web search or using a Slack API, using a calendar, and so on for complex tasks. Uh, Also want to quickly touch on when is a good what are good use cases for agents. So this a good use case is when the problem space is open-ended. It's like you don't know beforehand what the solution is going to look like. Like you don't know what the number of required steps can be. So for a complex problem, the agent could end up taking 10 steps versus for a more simpler task, maybe it just needs like three or four steps. And the agent needs to basically adapt based on the results it has seen so far. And we'll see these patterns in like detail later as well. Uh, and obviously, to be able to use agents, like the model you have trained or like the agent you have trained should be good enough so that you trust what it's doing, because otherwise its errors will just compound. Like for a complex task, like if it has 10 steps, you want to make sure that the intermediate decisions it's taking are actually good. Otherwise, you'll keep compounding on your errors and your agent will end up in an irrecoverable state where it's hard, like impossible to recover from. Uh, it's also very important to have, and we'll discuss this more, like clear success criteria and like feedback loops, so you actually know when your agent has done the task it was supposed to do, and then you can stop there. Also, equally importantly, if not more, is when you should not use agents. So you should not use them when like simpler things like prompt optimization will suffice. This is typically the this is typically the case with, let's say, the latest state of the art models, where the models have gotten so good that for a lot of things where you would have needed like fine tuning before, or you would have needed to gather a lot of data to make the model better at the task. But these days, you can just get away with like these uh, fairly detailed prompts because the models have become so good at like a kind of getting what your intent is and then accomplishing that task exactly as you intended. Also, when your task has a fixed predictable structure, like I said, it's more like a workflow, and you can kind of also do that. You don't typically need agents for those. Uh, Also, if your application is very cost sensitive or latency is a concern, I would think twice about using these more complex agentic setups, because these calls to especially frontier models are very, very expensive to make. So if you're making a bunch of these calls, or like for complex tasks, you don't even know how many calls you'll end up making. This is something important to keep in mind, that if especially if you have like tight constraints around either cost or latency. So yeah, basically like summary to remember is there. You're basically trading off quality. You'll get better high quality, but that comes is like no free lunch. So it comes at the cost of like latency and cost. So start with a simpler solution, and then you can engineer complexity if needed. And we'll discuss that in the following slides. Also, one thing to call out is for these frameworks, there are a bunch of frameworks which make it easy for you to get started, like at least in theory. But if you're using those, at least in my experience, I think one thing to keep in mind is make sure you are extremely familiar with what's kind of going on behind the hood. Um, and in case there are issues, which will almost always be when you're setting things up for the first time, um, mm, it's very important to kind of have that transparency so that you are able to debug. We'll also get into like basically the things you need to debug later, but basically a good baseline thing to start with is actually just start with like APIs, let's say, of these of whatever model that you think is good for your task, because that's the simplest possible abstraction. Like the model is only seeing your prompt, so you can be sure it's not seeing anything else that let's say the frameworks might actually be adding to the prompt behind the scenes, and this just makes it extremely easy for you to debug what's going on. In case you do end up using a framework, like I said, just make sure you know understand what's going on behind the abstractions and have complete transparency so that you're able to debug when things go wrong. Let's start with the sort of a building block which will be used in all of the like production patterns we discuss later. So you can think of it as the simplest possible agent, which is basically sort of a base model, which should firstly be like intelligent enough. If the base model is lacking like key capabilities, like no matter what scaffolding you set on top, there's no way I will be able to like accomplish like actually like non-trivial or complex tasks because it'll just not be like capable enough. So make sure you have a base model that's very capable. Once you have that, then basically the only couple of things you need on top is like firstly retrieval, like it should be able to access the right context, and if it doesn't have that, it should have the ability to retrieve the right context. Like let's say if you're talking about a huge code base, it should let's say have access to an API that lets it search the code base and it's able to retrieve the files that it wants. Uh, so I'm calling that component like retrieval, and memory like that is access to the right context, and if not, like it can actually retrieve the right context. And then it has this ability to call the right tool. So this could be like web search, like I said, it should be able to call some relevant APIs that it has access to. So this is kind of the like minimum viable setup that you need to then be able to use this in more complex patterns that we'll discuss. Uh, so pattern one is basically the simplest setup of having like a sequential set of prompts for each step. So you can break the task into either a predetermined or a variable number of steps. And the key thing to keep in mind is that after every step, you'll have very well defined success criteria, or like these like checks, which only after that check is successful, like based on the result, you'll then proceed to the next step. So this is good for more predictable or like more simpler processes with like a multi-stage process, which can still have typically an uh, a variable number of intermediate steps, but this is one of the more simpler setups you can use. So you basically, for each particular step, you have a very well-defined system instruction or prompt that you show the model with the relevant context. It does basically what it's supposed to do for that intermediate step. You will run your checks and then you proceed to the next step. So for most tasks, this can actually be a good setup to use. Like one example of that, like a very simple example is, let's just say if you want to use generative AI to generate some document, you'll start with an outline. For instance, your model can come up with like these are the based on your prompt. These are the kind of sections I think the document should have. There can be some simple like validation criteria to see okay these sections actually make sense. And the validation also want to call it can we'll get into this like can also be like a smaller model or like a smaller, let's say, an autorator which kind of rates like if the larger model did things correctly, and then you can go on to the next steps. And if once in the checks they look okay, then what you can do is expand those sections, and then you'll get a final document which you can do a final review on, and then stop. So again, the setup is kind of more useful for sort of simpler workflows, or like simpler processes where after each step you can have an intermediate check to make sure the output so far is correct before proceeding on to the next step. Another pattern that's really popular and makes sense in a lot of use cases is this model routing. So what you'll have is an initial model router, which itself should be a pretty smart, like a pretty capable large language model, because that's how you want to be able to, because that's the one that will be responsible for routing your request to more specialized models. So you'll basically your prompts come into this router, it will dispatch to more specialized models, which are very good at those specific workflows. What this ends up doing is actually, in a lot of cases, saving you significant costs, because your specialized models can be much smaller models, but they can actually have the same quality since they're only just or a better quality for that specific domain or task because they're specifically tuned for that task. So like an example of this is, for instance, if you have models that are trained specifically on like domains such as the legal domain or finance domain. So you can have domain specific models, and your router is just responsible for dispatching your prompt to the right model, which will then like solve it and come back with the response. A very important thing to keep in mind here is you should be really careful about like under or over triggering, and make sure your uh, requests are being routed correctly, because if they're not, you'll just end up sending a request to the wrong specialized model and end up getting a suboptimal response. And this is something that you always need to keep monitoring, like always keep checking your logs, always keep checking that your router is doing the right thing. And if it's not, make sure you keep updating your router and keep training on like your new logs data to make sure it keeps getting better. Um, I think, and I gave an example of this, but like a couple of more examples look like, for instance, if it's a customer service kind of a setup where you have a router model and requests come in, and you can reroute your request to like technical team or finance team. And when I say finance team, it could also be like models which are handling those requests. There's also this thing we'll see in like some frontier model providers where based on the difficulty of your prompt, they actually decide behind the scenes which model to route your prompt to. Because again, calls to the biggest, largest models are extremely expensive for like, for instance, for a query like what's the date today or what's like 1 plus 1, you don't need to send your query to the largest, most expensive model. So this is another use case where it makes a lot of sense to do sophisticated like smart routing and save a lot of costs while not compromising on the quality at all. Uh, this is another loop that's popular and makes a lot of sense for some contexts. Is basically this, you can think of it as an evaluator or an optimizer or verifier loop. So basically you have a generator which produces some draft, and then there's an evaluator which critiques it or tries to verify it. And if there are some issues, it like sends those issues back to the generator, and you keep repeating this process until you actually meet the success criteria, or you reach maybe some fixed number of max iteration beyond which you want to stop, because you also may want to make sure the user has an optimal experience. So you don't want to like keep this going and just keep the user waiting. The most important thing to keep here in mind is like make sure your feedback criteria are extremely clear, so you know like exactly when to stop and when you've actually met the success criteria. A great example of this is actually coding agents. So which fit very well into this in this kind of pattern. So you'll have basically a planning agent or a coding agent. So the planning agent comes up with the plan, and coding agent maybe writes the code. The code runs off in a sandbox. You get the results, and based on the results, you actually decide, oh, this actually looks good. Or if there was an error in the code, you'll basically make a new plan based on that error, and you'll come up with like new code, and this process repeats until you actually end up writing. The agent ends up writing working code, or maybe you reach some max number of steps and then you decide to stop. The basically different infra pieces you need for this. Like I said, like you need some way to get feedback. So for coding, it's actually easy. You can just send into a coding sandbox and you can get it, whether your code compiled or not, and what answer you ended up reaching, and if it matches like the answer, let's say you had in mind. Uh, you should also have stopping conditions, like I said, so you know it's very clear when to stop, but then you don't just keep this loop going indefinitely. Um, for other purposes, it can be beneficial to have human in the loop. For instance, when you're training, to make sure they are, you actually, there's ways for you to make sure if the model is doing things correctly. And also, even for inference use cases, when this is actually deployed to customers, like one useful intermediate point to have human oversight is, for instance, when your model needs more clarification. So ideally, it should be able to ask like clarifying questions, and like the user should be able to give a response. You might have seen this already in like some offerings such as deep research, where before going into its research, the agent actually asks clarifying questions just so that it gets more context when it needs to. And you should also be able to have like meaningful and graceful error recovery. Uh, some examples of agents in practice, like which work really well because they kind of fit very nicely to some of the patterns we discussed, are, for instance, customer support agents. So this is an industry which has been growing a lot lately, and a lot agents are doing really well in this setup because of these few reasons, which makes them fit nicely with the pattern we discussed. So for instance, they're clear success metrics, right? Where the ticket was closed or not, or if the user was happy with the resolution and what feedback they gave. It's also the actions can be these nicely defined APIs, which are easy for the agent to take. So that fits in very nicely as well. And there are these models that you can use to make this agents easier to try. So you can, for instance, have pricing that's based on usage to and only charge customers when the agent is actually doing what it's supposed to. Another example of agents I think all of us will be familiar with is like coding agents that have gotten extremely popular these days, because coding especially is very amenable to the agentic setups, because in training at least it's very easy to have these verifiable rewards, because you can have a test suite that runs on any change the agent makes to verify if it was correct or not. So you have these very nice feedback loops, and you can have these objective like quality measures. To conclude, I think there's a few things just to summarize as like basically what you should. This is how roughly your framework should look like. Like start with like a single prompt, or start with like some sophisticated like prompt engineering, because a lot of the times even just prompt, it doesn't actually even have to be sophisticated. Just prompt engineering is enough to get the models to do what you want them to. If that does not suffice, like then see if you can start with a sort of sequential workflow in the sense where you have these the variable number of steps, but after each step you kind of do some checking and then you proceed to the next step. This can be deterministic as well for like simpler setups, and before you decide that, oh, actually that is not enough for you and you need to do into like variable number of steps setup instead. So in that case, you can have this like more limited agentic loop where it's still kind of you still kind of have some idea of what the overall loop might look like. And if that does not suffice, then there's this like final kind of framework of this, just like your agent has complete autonomy to decide what to do, number of steps, like everything is in the agent's control. But obviously that comes with its corresponding engine like complexity in engineering this kind of setup. uh, but I think just some things to keep in mind is like always prefer simplicity over complexity. Don't over engineer unless like you have to, and the problem deserves that kind of like sophisticated setup. Make sure things are transparent, like you can look into agent traces or like the chain of thoughts to help debug what might be going wrong. And I think a good lesson to always keep in mind is always have like this good agent computer interface. Like always think kind of an agent's perspective, like what is the agent seeing right now. For instance, if it's a computer use agent, it's likely just seeing like the computer like screen or like the whatever screen it has access to right now. So just kind of try to kind of think of things from the agent's perspective and give it the context and the tools it needs to be able to do a good job. Like think what a human would actually need to do a good job in that case, and make sure the agent has access to those. So make sure it has enough tokens for its like thinking budget for like more complex tasks, and again have like very like complete system instructions. Give it like good future examples, cover edge cases, and again to call out this like an iterative process. You'll see some new loss patterns, and you'll want to make sure that you keep improving the setup and keep improving your agent on these tasks. Some do's and don'ts with respect to like evaluations is like keep, like I said, like keep measuring, keep iterating. This is something that you likely not solve in the first time you try it. So based on your usage patterns, based on your logs, based on your new loss patterns you see, keep improving your agent. Make sure evaluations are extremely comprehensive. Like this is a topic where again it has a lot of details and a lot of nuance, but make sure your evals are representative of real world scenarios, and make sure you can um, they actually correspond to what the users have in mind. And then so that, because unless you have good evals, you won't even know what you're hill climbing on or what you're improving on. So I would actually recommend starting out with evals, like very comprehensive evaluations first, and then using them as a sort of this guiding metric to improve your agents. And again, start with simpler agents, like start with simpler setups, and then kind of add more complexity when you need to. Yeah, so to summarize, maintain simplicity, always have a bias for simplicity, and only engineer more complicated setups when you need to, and the problem statement is actually complex enough. Make sure you have complete transparency into what's going on behind the scenes, and use that for debugging and keep improving your agents. And always craft this kind of an agent computer interface, keeping the agent's perspective in mind. Make sure it has access to all the tools it needs, and give it all the context it needs, and you'll typically be surprised by, if it has all of this context, like how good a job it's able to do. Thank you.